Okay, so welcome back. So example 1 says solve the following by isolating the variable. If necessary, all answers should be in simplified radical form. So this is why we spent time on the warm-up reviewing how to simplify radicals, because all of our answers need to be exact, okay? So this means exact solutions, not approximate. Okay, so for A, we have x squared minus 12, which was the example we left off on the previous problem. We knew the decimal equivalent from Desmos was like negative 3.464 and positive 3.464, but we need the exact solution, so let's talk about that. So again, our goal is to isolate x, and so inverse operations, I'm going to add 12 to both sides, so I'm left with x squared equals 12. Okay, now x squared is isolated, but we want to isolate x, so to undo a squared, the inverse operation is to take the square root. So I'm going to take the square root, and I'm going to automatically write my plus or minus because I know all quadratics have two solutions. So I left with square root of 12. And then we're always going to look at the radical, and we're going to ask ourselves, can I simplify that? And so hopefully, square root of 12, you should say, yes, I can. So we're going to do a little work off to the side. So square root of 12, the largest perfect square that divides into it is 4 times 3. Square root of 4 is 2. Okay, so my final answer is x is going to equal plus or minus 2 square root 3. Okay, so these are my two solutions. This means there are two real solutions, meaning it intersects the x-axis 2 times. These two solutions should always go together. If you prefer to write your answer out twice, you can do that. You could write x equals 2 root 3 and negative 2 root 3, and negative 2 root 3, you're welcome to do that. And in your calculator, I want you to check this. Type in negative 2 root 3 and press enter. And guess what? It's going to be the exact same value. Negative 2 root 3 is the exact value of negative 3.464 repeating. Okay, I could also do the same for 3.464 and 2 root 3. When I type 2 root 3 in my calculator, the decimal approximation is 3.463. Okay, so let's try another one. For B, again, my goal is to isolate my variable. So I'm going to use my inverse operations to move my terms over to the other side. Oops, don't want that. Okay. So I'm going to add 6 to both sides. And I'm left with x squared equals 0. Ooh, that's interesting. Whew, okay, so 0 is a number, right? And so when I take the square root of both sides, I'm going to get x equals plus or minus 0. But can we have a plus or minus 0? No. Okay, so my actual answer is x equals 0 and 0. Or some of you may prefer to write x equals 0 double root, and that's okay too. Either one of these answers is correct. It's still a solution. So what does this mean? It means I have one real solution because it's a double root, meaning it intersects the x-axis one time. My decimal equivalent, we don't really have to do that because it's 0 and 0. Okay, now I'm going to go to Desmos and type this graph in just for us to see. Okay, now I am going to type in y equal or x squared just for us to see the graph. Okay, so I graphed it in Desmos. Notice visually I see my vertex on the x-axis, which tells me I have a double root, and it just so happens that my double root is at x equals 0. So we have two solutions, x equals 0, comma 0. This is your check to visually see what's happening. Again, we see a vertex on the x-axis, which tells us we have a double root. It just so happens that it's at 0. Okay, example C asks us to solve x squared plus 8 equals 5. And so, again, our goal is to isolate x, so I'm going to subtract 8 from both sides, and I get x squared equals negative 3. Okay, to isolate x squared, I'm going to take the square root, and at this point we should pause because I have plus or minus the square root of a negative number. Okay, that's a problem. We cannot take the square root of a negative number. That's actually an imaginary solution. Okay, so at this point we would say, oops, why do I always do that? Sorry. At this point, our final answer, because we cannot take the square root of a negative number, would be no real solution. Notice I added the word here, or the word real, because all quadratics have two solutions. We are only focusing on real solutions. So there are 0 real solutions, which means it should intersect the x-axis 0 times. Obviously, we have no answer, so we can't write the decimal equivalent. So what I'm going to do is I'm going to graph this in Desmos, and I'm going to graph y equals x squared plus 3. So I took this equation and set one side equal to 0. You could have also graphed 0 equals x squared plus 3. Either way, we'll get the same answers. I want to correct myself. Do not type 0 equals. In Desmos, you can either type y equals x squared plus 3 or just x squared plus 3. And you'll get the correct answer. So notice if I were to visually double check my solutions, when I graphed x squared plus 3, my vertex is above the x-axis, meaning it does not cross my real axis, my x-axis right there. So it just confirms again that there's no real solution. Notice it equaled 42, but okay, so I was thinking, the problem we did before, what happens if it equaled 48? Okay, so I rewrote that problem and changed it to equal 48. I divided both sides by 6 to get inverse operations, and I was left with x minus 4 squared equals 8. And so from here, our inverse operations are the same, but I want to point out a difference in our solutions, okay? So again, when I take the square root, I'm going to get a plus or minus, right? Square root of 8 and x minus 4, okay? So again, we use inverse operations, square root both sides, okay? And then what we're going to do is we're going to simplify our radical. So simplify radical, question mark. Okay, and hopefully you should say, yes, Ms. Berniska, we can simplify square root of 8. So we know square root of 8, the largest perfect square that divides into it is square root of 4, square root of 2, which is 2 root 2. Okay, again, this is why we need to review simplifying radicals. So instead of 8, I'm going to write 2 root 2 plus or minus, and then I have the x minus 4 equals. Okay, our goal is still to isolate x, so I'm going to use the inverse operations and add 4. Okay, again, I'm going to put the constant out front. So some of you may want to do this. You want to write, which is okay. It's not wrong, but it's just not how you'll see any multiple choice answers written, any answers written on SAT, ACT. It's proper to always write the constant out front. Okay, again, this means my two solutions are x equals 4 plus 2 root 2 and 4 minus 2 root 2. Okay, again, either one is correct, but I really wanted to focus on what happens if I can simplify the radical, and the answer is yes, right? And so what you'll have to do is you'll have to do a little work off to the side to simplify that radical and continue on. If we were in class, I would also have provided some additional examples. So I wanted to give you guys an opportunity. So on scratch paper, in your notes, wherever you want to, copy down these two problems, and I want you to try to isolate x and solve for it. So notice in the first one, your first step, your goal is going to be to isolate the quantity of x plus 1 squared, and then use inverse operations, taking your square root. And for number 2, your goal is going to be to isolate x squared and then take the square root. So practice using inverse operations. Pause the video to practice, and then unpause to check your solutions. Okay, so for the additional example number 1, you should have gotten 4 and negative 2. Now notice square root of 9 is a perfect square, so you would have to keep going further and simplifying it down to 3, and then we can get our two solutions of 4 and negative 2. So looking at my answers, 4 and negative 2, they are rational, which means there's no messy decimals. And it tells me that I could have factored, graphed, or use inverse operations to get an exact solution. Now, factoring would have been a lot. So we'd have to expand this quadratic of x plus 1 squared, multiply by 3, move everything to one side. We could have graphed. Again, we'd have to move the 41 to the left side. But it could be done. For example 2, I got an answer of plus or minus 2 root 3, which has a radical in it, which tells me only inverse operations. Oh, I realize this word is messy. Tells me would have provided me an exact solution. I could not have factored it, and graphing would have only given me approximate solutions, which is not enough. So I would have to use inverse operations to get my exact solutions. So that's just a little additional practice to provide you some additional feedback and see how you're doing. We got one more video to go. It should be a quick video. Good luck.